Hi, my name is Kang, and here I already choose one topic to this assignment, that is resistive sensor. So my student ID is D02191020, and I am a student from section 2. Go next. For introduction, a resistive sensor is a transducer or electromechanical device that converts a mechanical change such as displacement into an electrical signal that can be monitored after conditioning. Resistive sensors are among the most common in instrumentation. These transducers do not generate electricity, hence they are called passive devices. That means passive transducer. And the fourth, the simplest resistive sensor is the potentiometer, and other resistive sensors include strain gauge, thermocouples, and thermistor. And here I am going to talk about these four gauges. And the theory of operation of the resistive sensor is this resistive sensor is depend on four factors. That is cross-sectional area of thickness, length, temperature, conductivity. We can solve this formula and solve for the resistor. So R is the resistance of the conductor in the ohm unit. A is the area of the conductor. L is the conductor length, and P is the resistive of the conductor. And based on the principle of resistive sensors, the conductor length is directly proportional to the resistance of the conductor and is inversely related to the area of the conductor. L is denominator of conductor length. If needs to change the resistance of a material such that the value of above factor. So I will use this four application to present that is a resistive sensor. That is the first one is thermistor, second is potentiometer, the third one is strain gauge, and the fourth is thermocouple. And these of them have their own basic principle and their own applications. For thermistor, there is a metal wire with change temperature, and its application typically is temperature and radiance and heat. For potentiometers, its basic principle involved is due to movement of sliders. Its typical application is pressure and displacement. The third is strain gauge. Its basic principle is R of wire semiconductor due to elongation or compression. Its typical application is force and displacement. The fourth one is thermocouple. Its basic principle involved is voltage generated across the two junctions of dissimilar metal, and its typical application is temperature and heat flow. So now I'm going to present the first one application that I have chosen is potentiometer. The potential device is the most obvious application in its simplest form is two resistors in two series with an input voltage versus across the ends. If only two terminals are used at one end and the wiper is arc light, variable resistor or rheostat. Commonly, potentiometers were formerly used to control picture brightness, contrast, and color response in television sets. Typical of strain gauges are wire strain gauge, wall strain gauge, semiconductor strain gauge. And here, this is a picture for the potentiometer, and we can saw that they have 3 pins. One pin is connected to the wiper, and one pin is connected to VCC, and the other pin is for connect to ground. We only need to connect 2 of these pins to have a complete connection. Come next. Strain gauge. If a strip of conductive metal is pressed under compressive force without buckling, it will broaden and shorten. If these threads are kept within the elastic limit of the metal strip, so that the strip does not permanently deform, the strip can be used as a measuring element for physical force. The amount of applied force interferes from measuring its resistance. Okay, we can see this is the principles. When the strain gauge is tangent, the resistance is increased because its area is increased. When the strain gauge is complex, the resistance also will decrease because the area of the gauge is decreased. So we can identify the gauge factor. Use this formula. R is the length of initial resistance in ohms. L is the change in length in meters. And we divide it and can find the strain gauge. Okay, so with no force applied to the test specimen, both strain gauges have equal resistance and the bright circuit is balanced. In the first pictures, the bright circuit is balanced because no any force is applied to this test specimen. However, when a downward force is applied to the free end of the specimens, it will bend downwards, standing gauge one and compressing gauge at 2 at the same time and make a wishbone stone unbalanced. So in the picture 2, the strain gauge is compressed. So the area of here is increased. So the resistance also increase, and it can make the bright unbalanced. So the next example is typical the rheostat arm of the bright R2 in the diagram. Here R2 is set as a value equal to the strain gauge resistance if with no force applied. The two ratio arms of the bright R1 and R3 are set equal to each other. Thus, with no force applied to the strain gauge, the bright will be symmetrically balanced and the wattmeter will indicate the 0 watt. Represent 0 force once the strain gauge as the strain gauge is either compressed or tense. Its resistance will decrease or increase respectively, thus unbalancing the price and producing an indication at the wattmeter. This arrangement will a single element at the bright changing resistance in the response to the measurement variable mechanical force is known as quarter bright circuit. So we can identify this strain gauge using the quarter bright strain circuit. So we can set as R1, R3 is the same resistance. If the strain gauge is no any force applied, the wattmeter will show 0 watt because the strain gauge is in the balanced mode. When the strain gauge is become unbalanced mode, R1, R3 is same, but R2, R3 is the ratio of R2, R3 is not same, and bring that have some different potential have occurred, so the V will increase. So next, so the second application that I choose is thermistor. Principal characteristics of thermistor is an electrical resistance change in response to change in their temperature. Most commonly, the value used is negative temperature, coefficient has a resistance for as temperature rise. Semiconductor material that typically consist of a mixture of metal oxide. Next, need to use Weston bright circuits, and this application also need to use Weston bright circuits to identify it. So application of thermistor are zero power sensoring application, self-heat sensing application, and also liquid level sensor. And the next is we can see that these two figure above shows analysis using produce. Assume that the temperature variable resistance, this is RT1 as thermistor. When we set the internal temperature of the resistor as room temperature, it is 25, only 1.91 watts allowed through the LED, and this a little of voltage is not enough to light up the LED. When we increase the temperature in the resistor to 90 degrees, the voltage across the LED is 2.53 watts and the LED is light up. From the analysis, we can know that when the thermistor is begin higher temperature, the resistance will increase. When the temperature is reduced, the resistance will increase. This means the temperature is inversely proportional to the resistance. So next. So I think this one is wrong, because higher temperature the resistance will decrease. Yeah, this I type wrong, and this is true. This statement is true. When the temperature is reduced, the resistance will increase. So next, professional ethics responsibility during assignment completion. So during the assignment is done by me, some of the ethical responsibility I have applied. The first one is integrity. Do the assignment with all knowledge. Use creativity and mentally to solve the assignment questions, both hard and smart, to begin success and this course. And the second is modest. Complete this assignment with modest ethics. No share complete answer to others when complete the part of assignment. If other student ask me questions, I will teach him or her until he or she realize the part of assignment, and no copying answer from others. Do this assignment honesty. And the third is discipline. Not any cheating answer from other to easier and complete the work, and did not copy answer from other to be work or be curtain rules. And this is the difference I have used when I done this assignment. So we can see that I already searched these two lines is search for resistive sensor, and I also have searched for thermistor, strain gauge, potentiometer, ethics, and responsibility to complete assignment. So next, okay, this is all for me. Thank you for lecture listening. Okay, bye.